Hello, and welcome back to the Networkin' Podcast. Myself, Bruce Wallace, and my magnificent co-host, Aaron T-Ball James, are here today to talk about NAPALM.
NAPALM.
Yeah, you like that? T-Ball James?
That was good. We talked about the whole middle name thing last time, and you never put it into a...
Yeah, I remembered this time. I remembered.
So this is part of our network automation mini-series. This is the first of our technical... I was about to say technical deep dive, but I actually don't think it's that deep. So I'm going to say technical overview,
Plunge.
technical...
Shallow dive
into network automation frameworks and tools.
Yeah.
All right, first up.
So first up is NAPALM. So we did do a podcast a couple of weeks ago. We talked about various aspects of network automation, where we thought the industry was, where it was heading, all that good stuff. And we promised to do some follow-ups where we would actually take a look at what was genuinely out there, what was being used by operators today, where we saw those projects evolving to, where they'd come from, merits, pros, cons, all that good stuff is what we are here to talk about today. And the first project we've picked is NAPALM because it's simple enough. Scope is relatively small. I think we can cover it pretty neatly within a 20, 30-minute podcast. That's the goal here, guys. Short is good. Maybe. We'll try not to rant too much. But in general, we're going to take a look at NAPALM. We've spent the last 30 minutes researching. But, of course, NAPALM
Don't give our secrets away.
Yeah, the 30 minutes of research before the podcast.
Yeah.
Yeah, we don't want to give away too many secrets. So it's not that we're coming into this cold. This is one of those projects that we have had pretty direct interworkings with in the past within our work and life. So what NAPALM really is trying to accomplish, and you can correct me if your interpretation was wrong here, was a kind of vendor...
What if my interpretation was wrong? If your interpretation was wrong, you mean... Go ahead. I will interrupt you if my interpretation is wrong also, but continue.
Okay. All right. So NAPALM was really trying to solve a problem to do with, vendor normalization. At a high level, and you and I have talked about this before, that there's multiple layers, there's multiple levels in which this whole normalization endeavor can be undertaken. NAPALM is trying to do this at a fairly abstract, almost API level, trying to normalize the API towards devices in the network. And the end goal is that you eventually have a single uniform API across a number of different devices supported by different vendors, all normalized through NAPALM. So written in Python, I guess based on the research we've done, and this we could be stand to be corrected here, originally kind of developed within Spotify, opened up to a wider community, currently kind of maintained by some contributors from Cloudflare, Fastly, and the creator of NetMiko, which is one of the projects we are also going to discuss at some point.
Yep.
So it's been in the industry for a little while, multiple years at least. There's some vendors that have picked up support for NAPALM, and we'll get into what that looks like in a little bit. But it's kind of at the highest layer of this normalization stack, and I suspect we'll talk about that a decent amount today. In that, you can normalize at the API, you could normalize potentially even higher just through your own logic. You can normalize at the schema level. You can even normalize at the operating system, which is some of the motivations around Sonic. So I guess I'm interested to hear your thoughts on the correct layer to do this optimization. Does it need to occur at all, at some, at many?
So I don't know how much we want to talk about that versus getting into NAPALM, but I would say that NAPALM... where it should happen, that's a good question. On device, I mean, if you can implement something like OpenConfig, where the data model itself is unified, then on device, and we discussed this with Rob a little bit, but on device makes some sense. Yeah. What I think NAPALM is trying to do is provide not necessarily like a configuration abstract data model, but more from like a retrieving data perspective, because it does seem like they have a lot of getter functions and methods. And as far as setting, it seems like mostly you still need to rely on your knowledge of the specific operating system's data model, and specifically even maybe push down config snippets. And however that config snippet is formatted is up to, whatever that device is. It's not really trying to normalize that layer of it unless I miss something. But certainly from a getting perspective and retrieving information from devices, it's doing that. It's normalizing the data to some extent. So I see it really as a tool that is normalizing data from a retrieving information perspective. And if you have devices where they haven't yet implemented anything like Yang or anything like even as normalized as OpenConfig, then this tool allows you to go and retrieve data from maybe older systems that don't yet have that layer on the device that you can retrieve data from very easily. And yeah.
All right. Let's pause there because I want us to talk a little bit about the how before we talk about the why and the where.
Okay.
Because I think we need to context it a little bit on the goals of the project, at least at my interpretation of the goals of the project. So obviously, there's a lot of different vendors out there. Everyone's kind of gone their own way up until this point. OpenConfig maybe is a shift in that strategy and doing their own thing. And so clearly, the developers within NAPALM felt that there was a necessity to build a northbound normalization layer that could be leveraged across a bunch of different utilities. So this isn't a controller or a collector or anything by itself. It really is the library to normalize the interface to the device. So what that means is, like you said, there seems to be a heavy focus on retrieval of state. So this is, say you have a one-off script and you want to grab the interface state across the entire network. NAPALM, in theory, has a role to play there, I think, in that you could have a number of different devices, and as long as they had NAPALM support, you could issue, one call through NAPALM and get the input into whatever collector, whatever script you're building in a fairly normalized manner, which makes sense. But there is some focus on configuration as well. It's not as normalized in that they seem to focus mostly on the missing piece around transactions, because not all NOSes support transactions.
Right.
So there seems to be some kind of workarounds that they put in place to almost, I don't want to say trick the operator into thinking transactions are occurring, because they kind of are, but performing the transaction at a higher layer than the NOS itself. Because some don't support. The obvious downsides to this, right, are the use cases become fairly generic in that the power of NAPALM is only as good as the information it's able to extract. The normalization is great, but if you're only normalizing 10% of the system, is that going to be viable outside of those corner cases? And maybe we'll talk a bit about that. On the set side, I really don't see the value here. I mean, you could argue that there were NOSes out there that didn't have transactions, that some mechanism to do this kind of stuff is valid, but the direction the industry has gone in is that this kind of interface, this configuration interface, is normalized through something like GNMI and the underlying data model. And since there's no normalization occurring here anyway, I don't think there's too much value. I don't know. What do you think?
Yeah, I was going to say, but I think it also aims to just simplify it is specifically a Python library, and it's specifically trying to normalize or generalize the way in which you interface. Firstly, let's start at the beginning, how you first connect an interface with your device, right? So the general idea is you would connect and open a connection to an Arista device in the same way as you would to a Cisco device, and some of the parameters you'd pass would be similar between the two. How that gets implemented to the actual device is up to that specific driver for that specific device. So in Arista's case, it may be using their Pi API, and maybe in Cisco iOS, it's some other connection method to get and do that. But from exposing that through Python in a Python library, they look very similar. So from a NAPALM perspective, you would open a connection, and then how that gets opened is up to the implementation for that given device. That's the first thing. So it tries to normalize that so that you're not dealing with, I'm interfacing with an Arista device. I therefore need to open a connection in this very specific way. Or, I'm interfacing with a Juniper Junos box and I need to open a different connection, right?
Yeah,
So,
yeah,
so
indeed.
that's the
I mean,
first step, right?
I would argue that the industry has kind of moved towards standardizing that interface.
Agreed. But again, if you think about it from the perspective of you're dealing with a bunch of devices that you may have had around for a long time, you may not have been able to upgrade the software on these devices to support these new, more standardized way, like NetConf or GNMI of interfacing with the device. And maybe you have a bunch of new devices, like a bunch of new Arista boxes, which have their own API on box, and that's what you're using to interface. So you have these different methods in your network. So this provides you with a common way until you manage to get to the point where you've normalized that connection method to be something like GNMI or NetConf across all your devices, in which case then you can now incorporate that into your Python tool set. This gives you a way of normalizing that connection method through all sorts of devices which may not yet support newer connection types, right? And then that same thing goes to what you were talking about with regards to the transactions and managing configuration. So there's a few methods defined in NAPALM which have to do with configuration manipulation. So pushing a config, committing a config, like you said, and now how that actually gets implemented on the back end on the actual device. Some devices which are transactional will most likely have a native interaction as a transaction and return the right data. And for those devices which don't maybe support transactions, again, older devices, older operating systems, then NAPALM may provide that abstraction, kind of like you were saying, that almost faking a transaction type of experience. But again, it's the driver being that, or the point being that it's common. So from a development standpoint in Python, you're not having to understand how you do commits in one operating system versus another, whether some support it, some don't. You just kind of interface with a single library, which then in the back end is handling it based on the device connection type, which you've established.
Yeah, I mean, I did see a lot of look. There's value here in bringing kind of functionality to older systems, older architectures that don't support some of this new wave of management stuff that you're referring to. Mm-hmm. I guess the downside to that is there's definitely a shift undergoing in the management plane based on current gen operating systems. Like, there's no question there. I think the point you're making is that older style operating systems aren't necessarily undergoing that shift. They may be out of maintenance. They may just be in general otherwise indisposed and unable to evolve.
Or I'll interrupt you, sorry. Or that you haven't yet operationalized upgrading the software to the version that supports.
Sure.
Even though
sure.
You know what I mean?
Sure.
Yeah. So if the operating system has evolved itself from the vendor's perspective, but you haven't operationalized that new vendor operating system, and therefore you're stuck with whatever you've been working with for the last 5 years.
Yeah, I guess the issue here is there motivation in those kind of deployment models to bring in another layer that is doing this abstraction. I mean, if you were introducing another vendor into those layers and there was some kind of inflection point to rethink your management story, those boxes are managed today, right? Is the mm-hmm. point I'm making. So maybe that's using SNMP, maybe that's using a mix of CLI scraping and some other things. But there's clearly a management story around those platforms today. Do you think NAPALM is adding anything of value outside of the multi-vendor angle, assuming you already have your network being operated and configured today? Like, is there motivation to go back and modify what's currently working, or does this need to ride on an inflection? And is that inflection being outweighed by this whole model-driven GNMI NetConf push? Is kind of the angle I'm thinking on here.
Yeah, I'm actually not sure that this is really. I assume if you're at an inflection point and you're getting a new set of devices or operating system or upgrades, whatever it may be that inflection point looks like, and you're getting to a place where you may have new interfaces, like we keep referring to GNMI or other interfaces, then maybe this doesn't make sense. But where I see it makes sense is those one-off operational scripts that we briefly mentioned in our introduction podcast to networking. We talked about some of the 4 or 5 pillars that we each felt network automation had. One of the pillars was the one-off script, the one-off operational change a description across multiple interfaces, those types of interactions, I think this does provide some value. Again, in the context of not having a unified management system that or transport or data model across all your devices. If you were talking utopian world and you happen to have a new set of devices that are with a brand new operating system from your favorite vendor and that now supports a different type of transport interface like GNMI again, or a set of data models that are unified, then this becomes less useful. So in my opinion, it's really, again, coming back to where it's used and when it's used. And to me, that's...
Okay. So we agree this is not going to... Well, it's not going to make a monumental impact from an industry direction perspective, or it hasn't made an impact from an industry direction perspective.
It's a useful tool to me in those specific environments, you know?
Yeah. So let's talk about some of the cans and cannots of it then. So obviously this is a normalization layer, which means that somebody, either a vendor or maybe the NAPALM developers or somebody else, are going to have to write the translations between a simple function like a get arp table and the underlying calls to the network element and the translation of that data to something that the caller is going to understand. And I didn't look into this 100% on if the get functions are expecting state to be returned a certain way, or if they're just providing a mechanism to pull the state and it's up to the entity that's making the call to figure out what that state looks like. If there is, I mean, do you know for sure which way around it goes?
I mean, I think the response is always formatted the same way. It is expecting a certain amount of data to be returned in a specific way. So I think it is doing that aspect of it.
Okay. So I definitely can see some value here for like those one-off scripting style operations. It's typically going to lend itself to simple use cases where you want to retrieve something from the network, or you're performing, I would say, fairly simple configuration actions. I'd say realistically, if you're going to perform configuration and your operating systems already support transactions, you're not getting much other than a pass-through interface by doing this using NAPALM. In fact, maybe you're leaving stuff on the table. I don't know. So I don't see it so much from a configuration perspective, but they do have a lot of functions or methods around retrieving specific states. You know, there's get BGP config, for example, get BGP neighbors. And I could see these being tied into simple automation frameworks or simple one-off
validation,
scripts.
Just validation, even some simple validation scripts, you know?
Yeah.
And again, the key here being that because that data is returned, like it you know, your get BGP neighbors, for instance, or your get BGP in general function would return hopefully the same data regardless of what the operating system is on the back end.
Yeah. So, all right. So there's a place for this in, I guess, if you have a lot of different systems and you have fairly simple use cases, because I always see this as the downfall of these kind of utilities, right? They might provide some value, but that's often not enough value to warrant the operational cost of onboarding them. Like moving to NAPALM has a cost for an operator, right? And if it doesn't provide enough value and that you can only bring on board certain use cases or monitor certain objects through the interface, then that I think would be a sticking point for like any kind of widespread deployment of this. And that, like I said, unless it's a simple use case and you're not doing too much to the system, you're probably going to need this plus something else, or write your own custom functions, turn into a developer yourself. So for simple use cases, I think it works. The other thing is on the actual platforms supported. So today, supported for Arista, you mentioned that using their PyE API library. Junos using Junos, Easy, and C. These are all just the backend libraries that these various device types use. iOS XR using PyIOS XR, right. NXOS SSH, and iOS with a mix of NetMiko and PyNX OS. So
you can see just from this the kind of the driver behind having something like this is if you had a mix of EOS, iOS XR, and maybe some small Junos deployment in your environment, and you needed to go and you wanted to use Python to automate some aspect of retrieving, let's say, like you said, the ARP table or the route table. I'm not too sure if those are get functions as part of NAPALM, but let's assume getting the ARP table is one of the getters.
It is.
Okay, then you would have to go into, PI API, figure out how to establish that connection, figure out how to retrieve that information, normalize the response yourself, and then go do the same thing with your Junos. And maybe in this case, maybe it's Junos EZNC, and then maybe it's Pi iOS XR, right? And so for each of those, you'd have to go and create those connection, figure out what the build your own getter function or what the get function is that's exposed to you, and then normalize that data, and then do whatever you want to do with the data in the first place. And that's where you can see something like NAPALM coming into play, where now you don't have to worry about, you import the NAPALM Python library, it's supported across your devices. Let's assume you have all those devices, and now you can just use a simple device connection method, and then a getter method to retrieve the information you need, and it's all returned in the same data format. But again, it's very specific. It's a very simple use case where you're trying to do very simple things, but it works in those environments, right? And that's where that just by looking at that table, it shows you the value to some extent.
Yeah. Yeah. And I guess the long-term maintenance, I mean, actually, before we jump into the maintenance, I wanted to highlight the transports and the backends that are in use here, right? NetMiko obviously being SSH. I think one of the iOS XR or NXOS is also SSH, and the other is HTTP. So are you surprised to not see any of the model-driven interfaces / their supporting libraries here? I mean, I was a little bit. Maybe that was just a sign of when things were developed, but
I think that's it. I think it's more of the when things were developed and the driver back then. And, nowadays, maybe with, as I said, with your more modern operating system versions, it reduces the value of something like NAPALM, because maybe you do have that more standardized interface and even to the extreme, as we said, even a standardized data model. So if you're using GNMI as a standard interface and you're using OpenConfig as your standardized model, then retrieval of information across EOS, Junos, and iOS XR, assuming they supported GNMI and OpenConfig, is now standardized, right? And then you're using a Python library for your interfacing with GNMI, and you're maybe using PyEngBind to create a way of manipulating and retrieving the data models based on OpenConfig, or the bindings, I should say. Sorry.
Yeah. I mean, you have to commend kind of the return on investment model that they have here. Like by going after the simple use cases, by going after the most widely deployed operating systems and the type of operators that would be on the path to building some pieces of their automation story themselves, you are able to do a lot with relatively little development work. Like, so when I look at what's supported in NAPALM, all I'm thinking about what is missing, right? But if you look at and we know based on the vendors that this is heavily focused on something like a fairly large scale data center, or anything that has relatively kind of carrier grade switching in mind. They're covering a lot of ground with what they've done. Like, there's no services here. You're not going to build EVPN services using NAPALM unless you're just, throwing down configuration blobs through their config methods. You're not going to retrieve information around EVPN multi-homing or ESIs or anything like that using NAPALM. But if you want to look at network instances, neighbors, BGP neighbors, most tables in the system, I actually didn't see a route table in there when I looked briefly. I saw ARP tables, I saw ND tables, LLDP neighbor tables, MAC tables, and I saw route lookups, and maybe that function, if you don't call it with arguments, gives you a routing table. I don't know. I didn't look that far into it, but these are relatively simple operations. They're fairly ubiquitous with switching and routing in general, so there's going to be some relevant data to return for most of these functions on most of the operating systems. But it does fall prey to the multi-vendor problem in that you have this support matrix of versions, vendors, and the functions that you're trying to onboard them with. And I think they've been good in getting some vendor backing. I mean, you and I know of at least one vendor that has gone out of their way to build NAPALM drivers. I don't actually know who developed the iOS XR and Nexus and EOS drivers.
If it was Cisco or Community. Or,
yeah. But I guess the maintenance long term, I mean, you and I have had this debate many, many times along, changing schema and text scraping. It looks to me like the vast majority of the front end of this, like the bit that's doing work that's written by a vendor, is most likely text scraping. Now, it's text scraping structured data, so it's in some cases. In some cases, it's not. In a lot of cases, it is just running a show command, scraping the data, and normalizing it for you. So anytime you're doing that kind of normalization, it's prone to failure across upgrade cycles and things like that. So they've been around a decent amount of time, I think like almost 5 years. There's been relatively decent industry adoption for the last couple of years. So maybe this is not a real thing and it's just not a hurdle that they need to get over. But yeah, I always find anytime you're just trying to normalize something by text scraping, as soon as you support that for more than a few things, more than a few operating systems, I can see the maintenance headache this generates, unless it's distributed to the people who own the drivers. So, if Cisco writes the Cisco driver and it's part of their build process to update that driver when they do releases, then that's a viable model. But I don't know if that's how this is working.
Yeah, no idea. I actually don't know.
They do have a few good integrations as well. They focused on pretty decent return on investment there with Salt, with StackStorm, with Ansible, of course, as kind of the underlying, as you said, the interface normalizer towards these devices. So their go-to-market, even though it's open source, I don't know if they have a go-to-market. At least it...
you can use that terminology in this case. But
it does make sense. I do wonder if sometimes this is like... Normalization is a complex problem, right? You and I have talked about it a lot. Where you do it, how effective it is, how does it evolve, how does it change, how do you not upset northbound systems? There's a lot to unpack here. And I think maybe taking the simple approach is what has made NAPALM viable. And that they're not trying to achieve world domination through normalization. They're just trying to solve for the majority of simple use cases that exist.
Yeah, I think that's the case. And especially if you're a network engineer who is getting into software development or automation, getting into that world, something like NAPALM provides an easy step into it, right? So that normalization of, again, like the connection and even retrieval of configuration or setting a configuration, replacing configuration, and retrieving a bunch and having a bunch of getter methods with standardized data return does help a little bit in your learning process. And you just have to learn, it's easy to use NAPALM. There's lots of examples out there. It's a simple, and then regardless of what device you have and you're playing with, it's a nice tool to have. So I think if you're like getting into it, NAPALM is a good tool to
get started,
to help you get started. Yeah, for sure. And usually when you're getting started, I mean, again, let's be real. When you're a network engineer and you're getting started with automation, you're getting started with the development, you're probably tackling a very simple use case, right? You're probably tackling the retrieve a set of information across all my devices, or set of basic information across all my devices, and that really hits the use case with NAPALM, right?
Yep. So if you have simple use cases, you have older systems that you're trying to do normalization for and bring them under your kind of more modern development or collecting platforms, NAPALM potentially is a good choice for you. If you have something more complex, or you've kind of leapfrogged this level of abstraction and are going straight towards things like OpenConfig, or driving things using standard interfaces like GNMI with even proprietary models, or going even a step further and normalizing the operating system level and just deploying something like Sonic everywhere, then NAPALM probably isn't for you.
Exactly.
I did notice that there's no functions for Sonic here. I actually found that a little surprising, given, I mean, I don't know if NAPALM is an OCP. I assume it's probably not. It's maybe too small of a project, but...
But you need two things for that to happen, right? First, you need people to be deploying Sonic.
Okay. I didn't want to turn this into throwing stones.
That needs to happen. I'll stop there. Otherwise, this will turn into like the last podcast where I ranted.
Exactly.
I had a 10-minute rant on Sonic.
Let's stop there. All right. I don't have any last minute thoughts on NAPALM. I think we've covered this reasonably well. Unless you want to add anything.
I'm good.
Finish in 30 minutes.
No, I'm good. How long was that? 30 minutes?
Yeah.
Damn.
Just a lonely 30.
Oh, man. All right, cool.
All right. Thanks for tuning in, guys. We hope this was a good introductory session on NAPALM. Maybe it's right for you for your current project. Maybe it's not. We promise to have a rundown of a few other projects that are in the same vein. Some of them in lower levels. I mean, we're going to talk about NetMiko or Nornir at some point. If you're on the cusp of making a decision, maybe wait until those podcasts come out. But otherwise, we hope you enjoyed. We'll drop some links to some NAPALM collateral in the description of the podcast so that you can get started, look at the functions they support, see if it's suitable for you. And we will catch you in the next one.
Bye-bye.
Hey, everyone. Thanks again for tuning in. As always, please do let us know any feedback or criticisms you may have. We can be reached on Twitter, YouTube, or our website, ntwr.kn, where you'll find this episode and many others posted. For those of you on YouTube, if you liked the episode, please hit that thumbs up button. And if you didn't like the episode, feel free to hit the thumbs down button twice. On a side note, you know those cliche, "these are our opinions and not that of our employer" statements you hear all the time? Yeah, we unfortunately have to make one of those. The benefits of working in the industry we want to publicly have an opinion about. We've done our best to remove bias, but we're only human and we make mistakes just like you. Thanks again. We'll see you in the next one.